Hello everyone, welcome to the video explanation for Brian Passwater's topic 1-5 notes, example 7. Example 7 is asking us to determine if the following polynomials are even, odd, or neither. We need to remember that this has absolutely nothing to do with degree, okay? Nothing to do with degree. You cannot just look at the equation and go, oh, its degree is even, so it must be an even function. No, absolutely not. That is not what we're looking at. Okay, what we need to do here is we need to figure out if the function is symmetric across the y-axis, symmetric about the origin, or neither, even, odd, or cannot be determined. Now that's very, very easy to do. What we do is we figure out the two output values of the function, h of 1 and h of negative 1. That will tell us everything that we need to know. So we plug in 1, 2 times 1 to the 4th minus 1 squared plus 5. That is 2 minus 1 plus 5, which would be 6. Then we do the same thing for negative 1. 2 times negative 1 to the 4th minus negative 1 squared plus 5. That is still 6. So in this case, we see that h of 1 is equal to h of negative 1. What does that mean? That means that f of x is equal to f of negative x. That, where they're the same output value, tells us that a is even. Okay, we can do that anytime we're given an equation. So we're going to do the same thing for k. We're going to find k of 1 and k of negative 1. So we have 1 cubed plus 3 to the first minus 1. That's 1 plus 3 minus 1, which is 3. We're going to do the same thing for negative 1. Well, negative 1 cubed is negative 1, minus 3 is negative 4, minus 1 is negative 5. Okay? This is neither, because k of 1 does not equal k of negative 1, which means it is not even, and k of 1 is not the opposite of k of negative 1, which means it is not odd. If it is not even and it is not odd, then it is neither. All right. So next up there we have a graph. On that graph, we can very clearly find the output values for 1 and negative 1. Here we have negative 1, 3, and here we have 1, negative 3. Now I don't know what this function is called, so I'm going to call it f of x. Here I have that f of 1 is negative 3 and f of negative 1 is positive 3, which means f of 1 is the opposite of f of negative 1. This is an example of an odd function. They are opposites. One is 3, one is negative 3. They are symmetric about the origin. The output values are opposites for these input values that are opposites. D, we are not so lucky. It's actually fairly easy to do as well. Again, we look at when x equals negative 1, what's the output? When x equals positive 1, what's the output? Well, again, I don't know what this function's called, so we'll call it g of x. G of negative 1 is 1. G of positive 1 is negative 3. So they are not the same, and they are not opposites, which means it's not even, it's not odd, which means that part D is another example of neither. It does not have any symmetry around the y-axis or the origin. It is neither.